Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 141 linked list cycle. We're given the head of a linked list and we need to determine if the linked list has a cycle in it. And we're told that there's a cycle if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to know the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. This is just a little note over here, and we return true if there's a cycle in the linked list, otherwise return false. So in this example over here, there's a cycle. We go to 3, 2, 0, 4, -4, and normally you would end up at null and end the linked list, but instead here, our next pointer points to 2, and so the cycle just keeps going. Say for example 2, and we return false for example 3 because there is no cycle in this linked list. So we're given some constraints. We're told that POS is a valid index in the linked list. So how can we solve this problem? Well, there's quite an easy solution to this problem. There are like algorithms like the tortoise and hare algorithm, Floyd's tortoise and hare algorithm that we could use, but the simplest solution is just to use a hash set, store each value in that hash set, and if we come across it again on the next traversal, we know that we'll find a cycle. So let's create a hash set. Hop in straight into the code, create the hash set, and we'll set our head equal to colon, because this is just best practice. It's basically just semantic. We don't need to. We can just use the head variable, but it just makes it clear that we're traversing and not modifying the head. So let's say while colon, if our current node is in our visited hash set, then we can return true because we find a cycle. Otherwise, we'll add to our visited hash set our current node. We'll say current.next is going to be, well, current is going to be equal to current.next. So we will shift the next node, and we will return false if our while loop finishes, because that means we have not found a cycle. So let's run our code. Pass it through test cases. Let's submit our code now. Pass all 29 test cases. So in terms of time complexity, well, it's just a single pass, so it's going to be O of n time complexity. Space complexity, worst case scenario, we will store the entire node list, linked list in our set. So all the nodes of our linked list in our set. So it would be worst case scenario O of n space complexity. So both space and time will be O of n complexity. So I hope this video made sense, guys, and I'll catch you in the next one.